achieve, eh? It's like
It would add so much to this room. And
so
yeah, it's
much
been done
color.
before.
Okay, how do I get out of this? Okay. Ready? I got some questions. I got some names. I like talking to you about names because you have a fairly instinctual and guttural kind of a reaction if I get it wrong, and you make a funny cooing sound when I get it right. So it's sort of like a good test there, right? You can't really get that.
That's
And you can't fake it because it's like your first token. So you don't, like the first token is the most important one, they say. Okay, so here's
you
some.
just described me like some kind of naming Furby.
I was
You know,
thinking more
just
like a naming non-reasoning LLM, like a very
Ooh.
deep but fast. Yeah.
Mm.
Well, I mean, those are the signals I get, right? Like, and then there's this clucking sound. You're like, I don't even know how to do it. You're like, oh, like, hmm. Well, and if I've really missed the mark, I get okay. And like, okay,
That's the first one I've
that's
heard that.
one name. We could
Oh,
name
that's
it
the
that.
middle. Oh, all right, so I've got middle as well as
Like,
the. Mm.
it's like, that's a. Let me think about that. All right, so agents. I know that we said that it was overburdened by the use of everyone else's words,
Mm-hmm.
but to not include the word agents in our system is to lose our connection to that deeper industry realm. And
Mm-hmm.
so I would like to place agent as, I'd like to choose where we put agent there, and it should be the most agent looking thing about our system. So I think that agent is what applies to it's actually a queue. We mentioned it last time as the virtualized agent, but it represents a work queue of all the interactions coming at that agent from other agents, where there could be multiple threads going on, or multiple concurrent requests from agents, but it all comes into this juncture point, which is the agent, and it doesn't do any prioritizing or any stuff like that. That's sort of up to the platform or the implementation to deal with that. So it's really just a folder on the file system with some triggers hooked up.
Hmm. It doesn't have much agency then if it's just a queue.
Well, it actually does have all the agency, but the other names I've chosen for things should make that become apparent. Now,
Okay.
the mechanism that I want it to do. Oh, maybe I can get the same effect that I seek from you with a picture.
Aha.
We do love us a good picture, we do. Hold on. Excalibur. Excalibur, whatever they call it.
You need to display your screen.
Oh, yes. Oh, yes.
Traditional.
Yes, I know, but I've got issues because the freaking camera pointer keeps taking my click. Every time I click, it just closes my monitor. Like, this is the weirdest. This is such a crusty experience. Like, we need new headsets. I'm sick of this. I've just had a guts full.
Really
It just
and
this is the
experience.
state of this environment is worse than 2 years ago when we first set this up. It has gone backwards.
I think they've just abandoned it, and I don't know why it's
Even
gone
if they'd
backwards. Even if they
abandoned it, it
abandoned it,
would have
it's
been
been fine.
better because it would
Yeah,
have stayed the same. But
yeah.
it has degraded. Okay, so I will reset the canvas. The agent, as you surmise, doesn't actually have much agency or feels like it doesn't because it's just a queue. So messages are coming into the queue,
Mm-hmm.
and then this is what the agent represents.
Mm-hmm.
But what's special is that every interaction that comes in, so here comes the first rename, what we'd called hosts, which are the computers that run what used to be the agent image.
Mm-hmm.
I want to rename that as a core.
Okay, quite like core. Core makes sense.
Okay, so you've got a core which represents the because I realize there's a lot of computing names that are actually up for grabs now because like you and I never talk about the computer cores on the
Yeah,
machines that run our stuff.
because
Like
they're abstracted away. Yeah,
we've gone
it's
so far beyond that
yeah.
that we never mention cores, and so that makes core back available again, I think.
I know. Yeah.
Um, yeah, so I mean, we started with computer, but so a core is what previously was the host. It's the thing that runs it's a Docker container, soon to be a CocoaNet container. It runs all the stuff, right? The thing that it's doing is processing a thread. So you might have like this message, and this one are all like part of the same thread. And so
Mm-hmm.
that's what gets run on a core. Like it's
And
one core per thread.
the interleaving things that you didn't do the little dash above,
Yeah.
those are where they come from.
The unanointed, they are different
Mm.
threads. So this one, where do I get color from my pen? Oh.
Mm-hmm. There you go.
Oh. So they would be, so this one, purple haggis over here, would be like this message and this message. And
Mm-hmm.
so the messages come in any order because it's a concurrent system, but
Mm-hmm.
the agent is the queue, and it simply sends off messages that are destined for a different thread go to a different core.
Okay, so as far as I'm concerned, say if I was human talking to one agent,
Yeah.
uh, that agent is also talking to a dozen other humans. So I've got the black dashes, you've got the
Yep.
mauve, whatever that, I
Mauve.
don't know what that is.
Yeah.
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 But as far as I'm concerned, I'm asking it things, and it can ask it additional things and queue it up and so on,
Yeah.
and it's responding back to me.
Yeah.
So the agent really, it looks like the prompt box, even though it's abstracted away the fact that other people are also asking
Yeah.
the agent.
Yeah.
I never see that. I don't care
No.
what it is. This just takes slightly longer, maybe, and it's going to different cores. I don't really care about that either.
Yeah.
By definition, is it? Yeah. There's multiple agents on each core, right? Or is it
No.
one core with
No.
one
No. 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 That's
agent?
the thing. Okay. So the thing that the core runs was used to be what we'd call it was an image, but now I want to rename that to kernel.
Okay. Core kernel.
Okay, so you
Okay.
don't like that one, but there's so the
No. Give me a chance. I mean, kernel is like the bootstrap, isn't it? It's like it's well understood as the substrate of
well,
everything.
how I think the model works is I think that it's one kernel per agent. So when you make an agent, what you're really making is a reference to a kernel image, and a reference to a kernel image and a queue, and that's what makes it an agent.
Okay, so you could draw a box around lots of dashes and a Q, sorry, a K there,
Yeah,
um, and that would be effectively the agent boundary. That is what, as far as I was concerned, that would be the, you know,
like
uh,
that would be the bounds of what an agent is. The
yeah,
queue, the reference to the kernel, and the cause,
right,
and then
and
each core is running the kernel on it.
it's does it um, how does it get a message back? I'm not meaning specifically, but does it just say right next in the queue, next in the queue, next in the queue?
Well, so there'll be some settings that go with the agent. So what the kernel is one of the settings.
Mm-hmm.
What the concurrency limit is, like how many cores is this agent allowed? You could just say unlimited. That's fine. But if it's
Mm-hmm.
unlimited, then the queue has no back pressure, and every time there's a new thread, a new core spins up, which is perfectly fine.
Mm-hmm.
When what happens is each core, each kernel that's running in each core receives only the message that it was set up to process.
Mm-hmm.
And so it does its processing, responds, and then those messages just go back to where they came from.
So standard IO or something, whatever. Yeah.
Well, they'll all be on the file system, so it'll just write to the file system, and whoever sent it will see that this message that was written to the file system now has a reply by using a trigger,
Mm-hmm. Okay, so
which gets us straight back into blockchain land, because that's how the blockchain system was set up to work. It triggers it passes messages by writing them to disk, and then triggers responses by detecting that something's been written to disk in reply. Because that
mm-hmm.
works perfectly fine if you have a Git based file system, because your file system changes come in the form of commits, and they're very efficient to detect what changed, because you just look at the commit and you're like, oh, that changed, that changed, that changed. And it's very cheap to do that mode of comms, but it also allows for things like replay, repeated execution to check that it went okay, very long periods of disconnection, so that, like, all the cores got halted for years, and then they fired up and they'd like, oh, it's like we never left, and they just begin processing again.
I think this actually works quite well. Right, let me um, abstract this away. Uh, right, I text you.
Mm-hmm.
In this case, you're getting lots of text from other people, but you're responding at the pace that you want to whoever you want to.
Mm-hmm.
But all I'm getting are responses.
Mm-hmm.
So it feels like I'm talking to you. I
Correct.
don't know what else you're doing.
Right.
Uh, now, um, while doing that, so we got messages going in and messages going out, and really what you're doing is thinking about each, which is the kernel, like your experience,
Yeah.
right?
Yeah.
Um, and it's like, well, way beyond the point where I care, other than you know still be alive. You have a brain, which is the core, right? That's where you're processing your
Yeah.
experience in order to answer my message. But our interaction is really just what I perceive. I don't want to see the rest of the queue. but
Mm.
what I perceive is my queue of text to you and your queue of text to me.
Yeah. Yeah, you
That
don't
that,
you don't
that makes
see the
sense.
rest of the queue, and you don't really want to. And in this model, you would never even feel the queue. Like in the old model, because there was one core for the whole queue, you would feel that queue if a lot of people started asking questions, you'd be like, why are you so slow?
Oh yeah, you'd hit the size of the core much more quickly.
Yeah, but here the size of the core is whisked away. Like it's now the size of the infrastructure platform, not the size of
Yeah,
the core. And
yeah,
it's
yeah.
not as lossy as it might, or inefficient as it might seem up front, because it kind of it the cost scaling works very well. And so I think that when we make CocoaNet, we would make it a core oriented platform where it's designed specifically to be very efficient, to give you this core like abstraction where it's like, here's a unit of computing that's meant to be cheap, disposable, and all that, and confidential. And it's kind of designed for this processing, because all the confidential VMs right now are typically intended to be around for a long time and to
Uh-huh.
hold big jobs. So there's actually
Uh-huh.
nothing in the market that's taking these little jobs.
Mm-hmm. Mm-hmm.
But the studies I've done in it show that it's 100% feasible to do.
Is it a one-to-one mapping of queue to agent to kernel to core, or is
Almost. It's every agent has exactly one queue.
yeah?
Every agent has exactly one kernel, and every agent has at least one core. Sorry, zero or more cores, because you could start
Um,
in an error state.
why would I have more than one core?
What? To process multiple threads.
Um, oh right, yeah, of course,
So in
virtual.
Codex, so this is the
It's a it's
delicate.
a it's a it's a badge, isn't it? As we said yesterday, virtual agent.
Yeah.
Um,
So in Codex, and this is the surgeon's knife coming into play, right? This is where I told you that the devil, when I last saw him, he went down that way, and the knife to cut. So Codex wants to manage your threading for you. You can be on the same computer and you can start multiple instances and different bash prompts of Codex, and you can start interacting with it. Each of those threads is isolated from each other. It shares nothing with the other thread except the file system, right? So
mhm,
what we're doing is we're saying that under no circumstances does that type of behavior ever happen on a core.
mhm.
One core deals with one thread and only one thread. If you want to have another thread, you need another core. And that fits
Yes.
very nicely in the way that Codex is made, as well as the way that many UI applications are made, because they intend that the user can only be dealing with one instance of the app at one time.
Hmm.
And then for purposes of economy, because it's quite hard practically for most of us to start a new computer, a new virtual machine, just to run another copy of Codex so that we can have a second thread going on in parallel. That's why um, that's why it's important, I think, to make the cut there where we say threading. So this line would be a thread,
Hmm.
and that represents the messages that are all part of that same communication thread. Um, and then once it's done, that's it. Like the thread, the core always holds one thread at most.
Right. hence you got multiple cores because you got multiple incoming interleaved. What do you call them? Messages.
Messages, yeah.
Inter-
Well,
yeah,
they're the interaction messages that come in. They're the
yeah,
agent-to-agent communication messages.
yeah. Okay, that seems to work. Quite like it actually.
Why do you like it?
Because conceptually it abstracts quite a lot of stuff away. I don't care which core it runs on. In the same way as I was talking yesterday about the cores on a chip.
Because in a chip, right? Yeah.
Yeah, don't I don't. Well, normally I don't care.
But you only care
Fraction
when
of
you
the
run
time
out of
someone
cores.
does.
Like when it's
Yeah,
not performing well, you're like bollocks. How many
yeah,
cores? Like what's
that's
going on?
that's right. And the kernel I do care about because I want to know that, taking the analogy of texting, that I'm
Mm,
texting you and not Jude.
mm.
That would be a mistake. Um, so the kernel, which presumably the kernel, uh, I'll come back to that. But yes, the kernel is you, and so I'm talking directly to you as far as I know, and you're time slicing up in whichever way you want. And you got multiple cores, which are, back of your head. It's like about half dozen things you can have in your head, but this is effectively
Yeah, and
yours.
it kind of
It,
also makes it, I guess, semi-feasible for an agent to talk to itself without any kind of damage because it just makes a new core.
well, yeah, the agent would just add something onto its own queue.
Mm. So the benefits of having the cores like this is there was some interplay between as soon as we get the file system involved,
Mm.
there was some interplay that we hadn't really considered. It doesn't make sense to let multiple writable sessions take place because the file system that you're working on can be polluted across thread
Yeah,
processing.
we're saying
Yeah,
one has right,
yeah,
lots have
but it
read.
turns out
Yeah.
that even saying that one has right is a folly as well, because if one has right, it can corrupt the output of all of the read-only views, because that one that's writing is busy mutating the file system, and then the read-only views are getting a different look at it.
I thought we skirted on this yesterday, that the read was kind of snapshots and then consider and then output.
Yeah, but I mean, you
Not a
could do
snapshot, a
that.
lock, kind of,
A lock, yeah.
yeah.
Well, yeah. Once we get the Git NFS backing thing, it will be efficient to do that. Right now, it is inefficient to do that. But
Mm.
more to the point, I feel like the only reason you'd want to run concurrent threads on a core is to try and squeeze out some sort of an efficiency gain. You wouldn't do it if cores were completely free.
Well, yeah, but by making them completely free, you're making them expandable to the capacity
To
available
infinite,
wherever.
yeah, because I'm noticing there's this weird amount of complexity that creeps in as soon as you start to try to pack inside the unit, because now you just made a new level that you got to deal with. Now um
Yeah.
you're scheduling at a level, but it's sort of like what we learned about doing consensus. Like you should only do consensus at exactly one level, and your fault tolerance unit should be an entire virtual machine. That's what you should bin, not try and make bits of it more reliable than other bits. It's like just take it as a
Yeah,
whole
yeah,
thing.
yeah. Because then, regardless of where it is, you
Yeah,
can,
because
build in recovery.
if you multi-threaded inside of the core, you just built this structure that's surrounded to look like a strawberry. You put the strawberry inside the core again, and that's actually the fundamental pattern of complexity explosion. Is when you take a pattern or a unit at one level, and then you try and stuff it in to another one unnecessarily.
Yeah, yeah,
You just made the exact same mechanical thing here and then put it in there, and now you've got to deal with all these problems again, but just at that level. And so that's why I think this is a good balance of things, because it does the multiplexing, it does the thread scheduling, the multi-threading. It does it at exactly one place, at exactly one layer, and it's infinite. And this thing here, doing the multiplexing, is not a component at all. It's virtual. It's platform managed.
yes.
So it
I
can, right? So
yes.
it doesn't bottleneck. It does
What
not
was that?
bottleneck this bit.
What was that noise?
Which token is that? The Kakor.
Yes,
The
very much
Kakor.
so. Because also it's not hard to envisage if you had the strawberry in the core, as you were saying.
Mm,
You can't. You're getting in the danger of recursive kind of loop where the agent is trying to do its own stuff inside the core and going okay, let's try and do that, and
mm,
then you get to the limits of the core very very quickly and it goes fall over.
mm,
That's not hard to envisage. That's
mm.
inevitable actually. So yes, I agree. Um, and also, it's just easier to like get it in your head, and therefore easier for AIs to get it in the head if you're very clear about the division of labor here.
Clear and simple, right? One kernel, one core, one thread. The agent is a queue. It has
Yeah,
one kernel reference that it will spin up on as many queues as there are threads coming in. This queue is, for all intents and purposes, infinite.
yeah, but also as far as I'm concerned, as a user of that queue, I might be one of many. It still looks like I'm the only one.
That's right.
Yeah, that's lovely.
It's just like a
That's
prostitute.
that's yeah, exactly. You love me and nobody else. Of course you do. Um, that's quite elegant. I like that.
Okay,
There
that's
is.
good. The names, are you cool with kernel?
I like the uh, actor kernel
Agent.
core.
Agent.
Sorry. Uh, Agent kernel core uh, thread is my personal thread. Q is everyone lining up.
Right, the inbox, maybe,
The
is it?
inbox.
Yeah.
Yeah,
I
or
call
Q is also fine, but
Yeah, I called it Q because that's what it is. But as a conceptual model, I think agent inbox is a clearer way to think about it. It's just where
yeah,
all the incoming messages land.
yeah. And the agent in this case uh, is actually just a virtualized experience interaction between someone who's putting messages on the queue
Mm-hmm.
and getting messages back.
Mm-hmm.
Uh, and beyond that, it's being dealt with cores, but you just want that to happen until something goes wrong, and even then, it's usually someone else's problem.
Mm.
Um,
It also
where's
makes it. It
the
also makes the recovery part very simple. So, like, if a core crashes during execution,
yeah, yeah,
it
yeah,
doesn't
yeah,
take
exactly.
down all the threads, and then you're like, where was this core up to with these 10 threads that it was doing? Hmm.
Right.
Like, yeah,
Yeah.
like it was only doing,
It's
right?
like okay, everyone, right, take a step
Yeah,
back. What
right.
the
But
hell are we
here you're
doing?
like, okay, you were up to this message,
Yeah.
because the consensus of Git will allow the queue to be durable, and you're like, we didn't get that message. Okay, fire up another core starting with this message and this starting state. Go, and the recovery feels much easier to think about.
So the agent feels like a bit like a network router taking in TCP requests and then deciding where it goes, the actual
Right,
work being done in the core,
right.
and then, as far as
Yeah,
you're
right.
concerned,
Yeah, that's a
you
good way
don't
to
think,
think about it. It's like
yeah,
a router doing NAT, doing network address translation.
Yeah,
to the
yeah,
internal network, and the internal network can be, you don't know if you're connected to a university or just someone's home, but
right. And
you
if you
know,
think about this in terms of, just even a website, it maps over quite well. There's a whole bunch of requests coming into the website. I don't
mm,
know about anyone else's. I know about my click,
mm,
and I don't know where it's being actually executed. Don't really care. But I've got a place to go, website, which is a completely virtual thing. If you think about a website, it is only the evocation of computing resources. I don't know where that computer is. I don't care where the tin is. All I want to know is where the website, or how do I address that website, and that's the agent. The kernel, in the same analogy, is the website. HTML. Um, so this works. This feels quite simple.
all right. Um, now,
Where
quirk.
sorry. So we've got agents, kernels, cores. Where does the actual, what previously we called the computer, exist in here? Is it a core? Are there many computers where we could dot around cores and we don't really care, or is this whole thing wrapped in one computer? Or
I think the model of computer still stays the same as it was before,
hmm
where the computer represents a collection of agents, but
okay, it feels quite like the computer really is an organization. It's like
a trust boundary is how how I'd
yeah,
written it down as. That's really
yeah,
all it's there for.
yeah, yeah, exactly. And
But
inside this, you know, we know
it
that there's
also holds repos as well. So I don't know if that design choice needs to be reevaluated, but it feels like was is still a good one.
it feels like it, because even if you have an agent wanting to contact another agent so the agent running in a core inside of a computer wants to talk to another agent completely, um, then you simply expose, I guess, a port to the repo and say, hey, look at this, do that
Um,
on that repo.
mm, yeah. So the way I'd change that is that you can pass repo references around in the messages. So when you send your message into another agent, you can tell it that I want you to work on this repo. Additionally, kernels can be provisioned with requiring access to a particular repo as well.
Yeah,
Uh,
but a kind of outside of trust boundary repo,
mm.
um, what you're saying is you're effectively passing the address of the repo and saying, I'm cool if
The
you
rule I'd
look at.
made there was that you can't, as an agent, you can't work on a repo unless it's cloned into your computer.
Well, even for reads.
Um, yeah, reads I thought I was gonna allow, but then I was like, yeah, I guess reads I wasn't gonna allow actually because like, what if the computer moves or goes somewhere else? It's kind of like what you're asking for is to have the agent work on a repo, but the repo stays on GitHub and doesn't get pulled down to the local computer in any way.
Yeah, I see. Because if you were to shift it around, I mean,
Yeah, if
your
something, it just
pointer is
feels
like,
more brittle. Like, at least if it's in the computer can be recovered. So I don't know about those choices. I was just making easy to do pragmatic ones. I
yeah. At
I
the
don't know
moment,
what
we've
the
got,
right choice is there. I don't think I have to choose just now.
well, since we're on naming, I'd like to move away from computer being the name of the trust boundary. Actually, trust boundary is nicer. I was thinking org, or, you know, uh, something like that, because
You don't like computer anymore?
well, computer is such an olden where
Yeah,
would
but
it
it's like we just
seems a
took
lot of packets,
cores,
right?
right? We took cores because no one talks about computer anymore, really, right? Like
Yeah,
you're on your
yeah.
laptop, I'm on my phone. Like we don't talk about, I talk about my desktop. I don't really say my computer. I might say my server, my desktop, my
Yeah, I
phone.
guess you're right. I guess you're right because it's almost like an archaic word now.
That's right. And so we've sort of jumped back in history, and it's like how people start naming their babies after their grandparents' names, like Cyril or whatever. And you're like, you know, like I saw the 6 month old kid named Cyril.
Right.
I'm like,
Just call
who?
just got this new baby Fanny. It's like, yeah.
Right? Like
Nobody
it,
uses
they came
Fanny
back
anymore.
into turn. So in
Yeah.
this model, then you'd have the computers consist of a collection of agents and with cores. So the computer cores are these cores that run the kernels based on the agent queues.
Oh, there's an interesting thing there, though, isn't there? Because I would just let me trace through this because I'm not sure I understand it fully. I'd expect in the paradigm a computer to consist of a bunch of cores. Cores um, evoke a virtual agent with the kernels,
Mhm.
but where do the queues go?
The queues on the file system.
Right. Okay. So the queues are just another part of what we're talking about with repos and NFS and so on.
Yeah. So repos would be like a repo is effectively the database of the system.
Yeah. So the vertical dashes, actually you could shift those into your green bin
Right.
and then draw a box around the green bin and the cores and the agent itself being virtual. We don't know which core it's working on. For now, we're thinking one computer just to make life
Yeah. So
easier.
just to sort of be clear, though, one computer is one repo because it holds these inside the computer. These are just Git submodules. So the repos that are within repos.
Right, right.
And
So a
what that
computer.
means is that the computer, because the computer's a Git repo, one of the principles I came up with is that the whole computer must be recoverable from a Git commit. So if you have the Git commit, the latest Git commit of the computer, you should be able to reboot it and lose nothing.
But that would suggest that cores and therefore virtual agents don't really care about what computer they're on.
What? Yes,
So,
they do, because they need access to the kernel definitions. They need access to the queues because the queues are within the computer repo.
yeah, no. What I was saying is if everything goes dark, you can rebuild the this state
Mm,
because you got the repos,
right.
but
The
the
big
cores
repo.
are yeah the cores are
The cores are
um,
disposable.
right and don't
So
really
what? So
care.
the a core is ballistic until it comes back and returns its response to the message.
Uh-huh.
So you don't know, you could be running multiple cores in parallel to get consensus on the result, or
Yeah.
it could time out and you restart it. But the core is like when you begin processing, you are crashable. Like when you crash, you're going to restart from the message that kicked off the core. And only once the core has sent back its response have you ticked forwards and you're now in the next uh, crashable state. Like
Yeah,
the
that's
cores,
what it's
the cores are crashable. Like that, you lose the cores when you crash.
yeah, that's what I was thinking. So you imagine a data center rack where you've got a piece of box server and you've
Mm.
got um, big NAS or whatever you want to storage on, um, the the pizza box dies, gets
Mm-hmm.
fried. You can swap that in and out. The core seemed to be on the pizza box, but you can reinstantiate with a new pizza box,
Mm-hmm.
because you've got the storage
Correct.
and you've not lost anything
That's right.
except time.
That's right.
So it seems like the cores actually exist out by that definition outside of the. It doesn't care which piece of tin you're working on.
Oh,
I guess this
yeah, you're
is.
right. You're right. You're right. But there would be some kind of reference to that core within this computer database, because while you are running, you need to keep track of like what machine ID it was on, like there's some parameters about the core that you need to use. But you're right. The core could, like, these cores in CocoaNet could be split across, like, the whole world, and
Yeah,
you're just
which allows
connected.
for recover. You could
Oh,
even
right,
have.
yeah. The way I think about it is that this line that connects it back, or the connection to the broader computer, is just a VPN. So this core can be, you could have a core running in every continent on Earth, and it's still considered one computer.
Yeah, yeah, yeah. Um, and that's, I guess, I'll not revisit the computer thing, but no, that still works as a name. I guess I'm still remember when a computer was basically, a pizza box when you, rack
How
mounted
many other
thing.
people would remember a computer as that?
Probably not many, to be fair.
Okay.
Probably not
Would you
many.
like a different name for it?
No, because if all you need to do is overlay conceptually when you're thinking about this, that this is all in virtual space. None of
Yeah,
it is tied to any piece of tin, including the repos.
correct.
So all of this, you could add a V in front of it, virtual
Yeah,
agent,
yeah,
virtual core,
yeah.
um, and so on, and you still get the same kind of logical layout.
Yep.
All right. Okay. Yeah. Yeah. That works.
Cool. Okay. Um, so we got,
I'm really liking the uh, agent to core relationship. I think that works really well. It just
yeah, it does,
feels
right?
robust. It feels robust.
Right. And so when you come in from a viewer, oh, here's one of the quirks of it, right? It
Uh-huh.
seemed like we've gotten used to navigating into the agent using these VS Code web pages that pop up,
Uh-huh.
right? But now, because these cores are even more ephemeral than before, because they only deal with one thread, if you want to come in on a viewer, what I think what I think we want to do is, it doesn't make sense to just pass you off to land on a core. I think
Mm-hmm.
what we want to do is treat the web request like a kind of message coming into the agent, where it's like,
Mm-hmm.
hey, I want a web page. And it's like, oh, okay. And it spins up the kernel with that message, where the
Mm-hmm.
kernel knows how to fire up the VS Code server. So then you get attached to a particular core, but in your web page, in your URL bar, your address bar, you think you're hitting that agent, but all that's happened is the system has spun up a core for you that deals with it. So even if you hit refresh, or you make a new tab, because you're the same computer, you're the same browser, sorry, the same browser gets the same core. And so what that means is that if both me and you come into an agent, I'll get a different core than you.
Yeah.
So we're
Yeah.
not like, so in that way you could like share a URL to the agent, and it could um, handle like 1,000 people hitting that URL with the VS Code thing, and it just spins up more cores to handle it without
Well, yeah.
with very
Yeah.
little programming from the people that set up the agents. Whereas before, like right now, two or three people would tank the agent.
And yeah, the benefit of that is it lends itself to a system level virtual load balancer. Effectively, it's like
Effectively, right? It's
yeah,
scale, like auto scale
yeah,
for
yeah,
anything. But so here's what you lose with that. You don't get to, while this core is executing this kernel to process the current message of this thread, you don't get to look inside that directly.
yeah. Other than deep dive diagnostic is gone wrong, why would you wouldn't want to?
You wouldn't want to? Okay, great, great.
Yeah,
All right. So you would still, I can make it so that when you come in on a viewer, you can still see all the thread history as though it was one core that ran everything, because I can just make um, the codex home directory where it stores all of its. Let me just bring up an actual thing. So in the place where it stores all of its codex information, like the auth file, um, the history, so what I typed, all that can all still be on a single shared folder from the NFS share, so that even though there's like 100 cores, all it looks like from Codex's point of view is though it looks like I just started 100 different bash prompts and then started the Codex program. So you still have that sort of unification of feeling like you're on the same piece of tin,
yeah,
but um, but that's that.
yeah. No, no, exactly. And it deals gracefully with things like, oh, shit, my laptop with the browser session, it's just run out of battery. It died ungracefully. Um, and it's 2 days before I recharge it. The cores have been spun down because we
Yep,
don't want to keep them spinning.
yep,
I come
yep.
back in, and as far as I'm concerned, it's the same agent with the same thread.
From your point of view, yes.
Yeah,
Yep.
yeah, that's ideal.
Okay. Um, there were some other quirks too. Let me just check them.
This repo thing's really holding up, isn't it?
The repo thing?
Yeah, you know, essentially basing everything around repo and everything else is virtual, effectively.
Yeah, well
Um,
that's blockchain. Like once we learned how to relate those two things, it's like, man, that and this using NFS as a prototype placeholder for having a repo that was network oriented
mm,
is like so easy to get stuff up and running, relatively speaking. It's been quite liberating.
yeah,
Um, okay, some wrinkles, buddy. Some wrinkles. When I'm in thread, I'm executing this kernel on this core.
hmm
I then want to talk to another agent, but the thing
hmm
is that I don't know about other agents. I know about kernels. And so I
Mm-hmm.
want to talk to something by kernel name. So I want to talk to the image search kernel.
Mm-hmm.
So I think that what that would do is it would spin up a new agent with the kernel that I asked for.
Mm-hmm.
And then from then on, I would start talking to it as the image search agent.
Mm-hmm.
So the kernel represents an image, but the agent is therefore named by the kernel that it's running, right?
Mm-hmm.
But this is where the wrinkle is. Would there be a reason to want to start another agent that also ran the same kernel? And if so, what is its name? And how do I talk to it? Do I want two Bobs? Would I call them Bob 1, Bob 2? But why would I do that in the first place? If we had unlimited scale for any given agent, why does it matter?
What would happen if I wanted a massively parallel job where the message I'm passing in to each is subtly different,
Right?
but the kernel I'm asking it to do the same thing. So the input is
Is
different,
it
but
the
the
same
kernel's the
kernel?
same kernel. I just want 1,000 of them,
You would use a
or
single agent, and it would spin up 1,000 jobs. Sorry, 1,000 cores. It'd have 1,000 threads, and therefore it would spin up 1,000 cores.
right. So it's the I spin up 1,000 of these things. It's the thread that is the interesting part. That gives you the parallelism. Behind the scenes, I don't know how many cores, as many as you want. I don't know, care where they are
Yeah,
spin up, but it's the threads that I'm really talking to in terms of parallel, multiple versions of Bob.
yeah.
That works. Um,
Well, it does it though, like because are you saying now that if you got the kernel named Bob, then there's only ever going to be one of those in your universe?
no, it's almost like you want to address the thread. Um,
Oh shit! What?
so it's if I had 1,000 Bobs and
Yeah,
I was saying something subtly different to each one, the only difference between the Bobs is it's not the kernel. The kernel is identical. The
yeah.
difference is it's a slightly different thread for each one.
But why wouldn't you have just used an agent that was the Bob agent because it's running the Bob kernel, and then why wouldn't you have started 1,000 threads with the Bob agent?
You would do, but in a workflow, maybe you want to do, something snazzy like I'm going to kill 1/3 of the Bobs at random, or um, if one's taking too long, want to kill that. You're still talking to
Wouldn't
the
you just do
same
that with
agent.
threads?
Yeah, you kind of would, wouldn't you?
The question I'm asking really is to say that um, we made agent IDs because we had to start somewhere, right?
Yeah.
And then you started really wanting to talk. You wanted to address the agent by the image name, which
Yep.
which I agree with because I'm like, well, the agent ID is just completely bollocks. And when you got humans in a job and they come with a name like Pritesh or whatever, you sort of like
You kind of don't want that
you
because that's
don't
an
care about
extra
the
load,
person's
isn't it?
name. Like if you we care about names because we're humans and we respect other humans, but in terms of getting the work done, you really don't care what the person's name is. You care about their role, their speciality, and their access control level.
So in that example, then, if I were to, Bob is my agent,
Yeah.
and I want Bob to,
Observation.
that's
I'm gonna call my agent Bob actually, because so I can say that I'm like, and then Bob's your agent, and off you go.
sorry, that's Bob. Right, here are thousand different inputs that I want to uh, ask you,
Yep.
dump it all in.
Yep.
Um, yeah, you're right. I would not want to have to tell another agent create 1,000 Bobs. I would just want to say, Bob, here's 1,000 things I want you to do in parallel. Go
Yeah.
off and do it.
Yeah. So really the only difference between a core and an agent is the agent is the unit of multiplexing. Sorry, the unit of multi-threading in the system.
Yeah,
And it's in one very special place and it stays there. And but because of that, there's a consequence which says that for any given kernel ID, you can only have one agent that runs it because what the hell are you doing? Like there's no
you'd kind of want to, wouldn't you? I mean,
right. Like if
um,
you've got the HR kernel, you don't want another one. You want to just and you don't even want to memorize agent names, right? The namespace
no,
should be the kernel namespace, and that's all.
yes, because uh, yeah, isn't that so? Bob, run these thousand slightly different inputs into you. You know, here's a batch job, do it in parallel, do it in serial. I don't really care except for the time. It's up to you. Um, but I'm still only asking Bob because Bob instantiates the capacity to do the work I'm
Right.
asking of it. I don't want to
Now,
think Bob
there
zero
there
zero
are
one
some
zero zero
there are
two.
some differences between kernels when you get into passing in a repo. So if you there's two ways we go about that. We can still allow
Mm-hmm.
you to change repos at at whim, or we can say that a kernel holds the repo, and if you change the repo, you technically change the kernel because now it's got different context.
Yes, but again, how much do I care about that as a user? Say if there's 1,000 repos, and the job I'm giving in to Bob is to read this file from all the repos of this type and bring back, I don't know, a result. I'm still only talking to Bob, even though by definition each kernel and core would have to access one of those 1,000 repos. So the abstraction layer is still the agent.
Would you even want to call it a different agent because you gave it access to a different set of repos?
No, I would just want to talk to the same agent and say access this repo for
Right,
this
so you
job.
want to pass the repo config along with the interactions in the queue, right?
Yeah,
All right.
yeah,
So
or
the kernel could come with some repos that it needs that are part of its like it might be its knowledge base or something it needs to run, but when that comes it doesn't change or
right, right.
it doesn't change per job. So it might come with its learned rules about the user, and that would change every time that it ran, but the agent wouldn't know about that because when you talk to the agent, you don't get to talk to the kernel's internal repos. You talk to the workspace repos, which are they're not identifying. Like it doesn't identify an agent to have a different workspace. It doesn't make it a different agent. It's just a job
Yeah,
came in and passed the workspace along, right? That's really what you're getting at?
yeah, yeah,
Right. So the
yeah.
jobs,
I like uh, in the HR example
yeah,
exactly. It's like talk to HR, 5,000 people.
right.
You know, it's like okay, we'll do that in parallel, and each will have a repo of the
Okay.
details.
Okay, well
Um,
that's fine. So I think there's now I'm I can give you a bunch of problems, but I would like to start with a potential solution to it and then
okay.
go through those problems with that suggestion in mind.
Hmm.
if we were to use POSIX pathing, where forward slash represented the computer, and then every agent was like a directory within the pathing. And so you could have forward slash Bob is like top level Bob, but you could have forward slash Bob, which is now Bob at a different level, which means that you can have different versions of a kernel, different purposes, and different arrangements and relationships between them, but they're isolated in namespace. So that when I say Bob, it means Bob in what folder? Like where are you in the hierarchy, the parent-child hierarchy of agents? Where are you asking that question? Because that determines who Bob is.
Now that works quite well, doesn't it? Because you could have forward slash agents forward slash Bob 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 all the way down.
Yeah.
Um, Normally you wouldn't really care because the agent would deal with bringing back all the messages and so on. Because I'm talking to one Bob.
Yeah.
If I wanted to jump into Bob 96, I've still got the path.
Yeah, so the path allows you to distinguish which instance of the Bob kernel, right?
Yeah.
So if the kernel represents the name, but it's like it's not identifying it, the name you can only have. Oh fuck! Well, what are we gonna do about a name clash? What if someone names a kernel? So kernels need to be uniquely named.
Inside a computer, I think, yeah, that would be a reasonable thing
Well,
to do.
so inside of, like, for example, inside of npm, it's a requirement that of all the X million packages, they are all uniquely named. And so I
Yeah,
think we're saying that same thing about kernels, right?
yeah, yeah. I don't see that as particularly onerous. It's like, think of another name, or if there's namespace clash, Bob X. You know,
Right, but namespace. So the kernel registry is where you store the kernel images, and the registry can be scoped or can be attached to a kernel. So a kernel can have a registry of kernels that it knows how to point to, just like an npm package has dependencies. And so we can apply that same rule about resolution, where it's like, if you don't have the kernel ID that you seek, we go to the parent. If the parent doesn't have the kernel ID, its parent. If root doesn't have the kernel ID, network or some other configured list of fallbacks, so that we can sort of go back and back and back and back and back until we're like, oh, that's the one you meant, or that's the one that it resolved to.
yeah. Yes, I agree. I'm not completely swept up with how POSIX deals with anything above slash. In this case, it would be another computer.
Yeah, it's a network name at that point. It's a DNS
Yeah,
name at that point.
yeah.
So POSIX actually deals, when you say not swept up, you mean you didn't like it?
No, no, as in I'm not
You're not
clued
super
up.
familiar with it? Okay, well,
Yeah.
let me explain it. Let me mansplain something here. Um, this is, you can't really see that, can you?
Well, actually, no. Yeah.
Right? It's
So you've
so
got
you got like, you got
that is your
username at hostname colon slash. So that hostname can be a fully qualified DNS name as well.
yeah.
So
I'm
that's
feeling stupid now. Of
uh,
course it is.
okay,
Of
cool.
course it deals with it. Yeah.
Okay, so what we're saying now is we're going to use POSIX naming to name the agents, where the agents are named after the kernels that they loaded,
Mm-hmm.
where the kernels within any given registry have to be uniquely named, but the registries are scopable by path as well, so you don't get like no one has no one has dominion over the name Bob for a kernel ID, so they don't have to be globally unique. They just have to be unique in whichever registry that they come up in.
Yeah, and I think that's a very reasonable thing to ask because when I call Bob,
Right.
um, I'm calling it inside of a context.
Right,
Um,
yeah, right. And then so I guess we can deal with name clashes because like in the lookup chain, the resolution chain of kernels, I could easily have a collision on a higher up one, but it still obeyed the rule that within its registry it's unique.
yeah,
So what it can do is in the space that I'm using it, I can allow for aliasing where I say that this name maps to this name so that I can explicitly handle what I know is going to be a conflict, for
yeah,
example.
sure. And you expand that alias to the full,
Yeah,
full
and
bloodied
that saves
positary.
us from now. Another option we could do is say that kernels are identified by their hash, so that it's guaranteed to
Um,
not globally collide, and then you just name it friendlily. You just
you
name it.
could do that, but what's like gaining us because
It's not gaining much,
still,
eh?
no, still locally, you wouldn't want to have two Bobs doing different things.
Nah,
So it doesn't seem that we gain too
it
much by
doesn't.
doing
No, it
that.
doesn't really save anything, eh? Like it's the meaning of the name is kind of the key thing, really, right? Like
Yeah,
it was called Bob for a reason, and that's within the confines of this context. So a folder in our system then becomes the context or the environment that the agents are interacting in, and then that's what you really care about because that's the whole
yeah,
meaning of your problem or your solution. Your artificial life is defined by the names and the meaning that each agent has, right?
yeah, yeah,
Okay, and
yeah,
then so versioning happens because a kernel has different versions as it gets improved. The agent doesn't, the agent might not have the latest version, so the agent just has kernel ID, fully qualified resolution path, like where did it get this version from when it
yeah,
when it came to resolution time, and what version was it? And then whether or not it upgrades is sort of the responsibility of like a management agent or some other agent that can deal with testing the upgrade. Um,
yeah. But you don't want an upgrade going on during you're halfway through your queue.
well, that's
You
the
don't.
thing that's sort of so. If you did an upgrade, you could have an old kernel completing its job, and then all new jobs switch to the new kernel, and so that job didn't get axed. You could just axe it and be like, "We got a new kernel coming through, bang," and then you just restart it as though there was a fault. But that seems rude and wasteful. You could just let
Yeah,
it finish
yeah.
because these jobs are
It
meant
does.
to they're
It
meant to
does seem.
finish very early.
Yeah, because you could have lots of cores running kernels, and then there's an upgrade, and what? All your cores are dropped on the floor and then restart. It's like,
Yeah. So the graceful thing works so long as at some point the core does halt, and I
yeah,
think that yeah, like it should. Okay. Um. So we've covered kernel namespace. I'm gonna switch to using POSIX pathing to define
hmm,
the names of the agents. We're gonna ditch agent names as being distinct from the kernels, so
hmm,
that you only talk about the kernel that you're talking to, and that's that. And you can't have more than one kernel in a namespace or in a directory.
yeah,
Like it's
yeah,
got to be a different kernel,
which implies
otherwise.
a system level directory of some sort.
Sorry?
to ensure namespace non-clash. So
Oh, no, I just meant that within a given directory,
uh
where keeping in mind that a directory is a full-blown agent, but it's just the way it gets addressed. It can have children. So within
yes,
the immediate children of within the immediate children of any given agent, you cannot have the same kernel twice.
yes.
Okay. Would you ever want to have two versions of a kernel in the same namespace? Like old and new, and you're doing side by side testing, perhaps?
Again, it's one of these things. Would you ever want to jump inside the core? Yeah, you probably want to be able to do that, but that is not going to
Right.
be
So
a
that could be covered
daily
by
occurrence.
aliasing, where you could specify in the config for that agent, like, here's the name resolution overrides. Like, this
Yeah,
name, Bob Old, resolves to Bob at version blah, blah, blah. And this name, Bob New, resolves to blah, blah, right? Okay, so that
yeah, yeah,
works. That works just
yeah,
fine.
yeah.
Okay. And then how would you do? You got a workflow. Let's say you want to run it 10 independent times. You would have 10 independent threads that come into the entry point of the workflow and
Mm-hmm.
trigger it. And then I guess they'd just send their messages off to the agents that they needed to, that they looked up using the resolution process, to just talk to them, right?
Yeah, and that could even be at the message level. You could say run 10, 10 of these jobs, call them 1, 2, 3, 4, and you get back, um, depending on how you wanted to tag them, you get back tagged results because the agent will understand the fact that it's being asked to run 10 things, and
Mm,
you want those uniquely identified. So I would just prompt that in the message. That would work,
mm.
I think.
Okay. All right. All right. And so you're doing a workflow. So the way to go about it is you'd create a bunch of kernels that would do the things you want. Now, I was making kernels by making a blank agent and modifying it, or making an agent from a kernel and modifying the kernel inside it. Am I still allowed to, once I've booted this agent, modify the kernel while it's running?
That feels wrong.
Well, so do a lot of things, and then you get used to it.
Yeah.
Um, because
The
otherwise, if I don't do it, what is the process of experimenting with the kernel to change it to make the new one? Otherwise, I've got to make the changes on the kernel image, so while it's static and just stored in the registry, and then I got to boot it into an agent, and then I got to hit it to experiment with it. That feels clunkier than just saying, here's an agent, it's called Bob Test,
mhm.
and I'm going to just hit that. I'm going to make changes to the kernel and then hit it each time. When I'm happy with it, I'm going to say create, register the kernel. So I register the kernel with whichever registry path I pick, and that makes a new version, the next version of that
Mm.
kernel in that registry.
So, altering the kernel on the fly.
Yeah.
Um,
I,
that
I admit that you should be able to explicitly not do that. Like, you should be able to set up an agent, and part of the config is like, do not change the kernel under any circumstances except for an upgrade, right? Do not mutate the running kernel. Like you should be able to
Yeah.
set that as a thing, but when you're developing kernels, you definitely want to mutate the kernel in place, I think.
You kind of do, but you don't want to do it while you're still processing
No, that's the thing.
anything
That's the
else
thing. That's the
other
thing.
than.
What's good about that is that when the job has started,
Yeah.
the job takes a snapshot of the kernel and it runs with that no matter what's happening up here. And so if
Yeah.
I patch the kernel, it's only going to take effect on new jobs, new
Oh, well,
threads.
that's fine. That's absolutely
That's
fine.
right. That's a
Yeah, yeah,
great side effect because then this
yeah,
job finishes and then this kernel just goes, yep, next.
yeah, yeah. So you run a long-running bunch of jobs, and then you can change the kernel at the agent, and the next message comes in. You're still going to get the previous ones back, and you're going to get the new results from after that message kicks off another bunch of jobs. You're going to
Mm,
get different messages back, but you know
mm,
you're running on the new kernel.
mm.
So yeah, that works.
That's fine, right? That's rapid
Yeah,
iteration. And then you can even like look at the results of like, you can fire off a bunch of changes quickly, like go change message, change message, change message, change message. The jobs might take 10 minutes. Then you come
yeah,
back and then you've got all these different jobs with different kernels, mutated kernels, and then you look at them as a batch and go, which kernel change did I like? Well, this
yeah.
one.
How would you
It's starting to
know?
take shape.
Yeah, how do you know which? If you were to do that, change the kernel while a long-running job is going, then kick off the new kernel, which happens to be faster,
Hmm.
and it comes in before the previous set of kernels.
You could cancel. You could reset the job. Like you could reset the core.
Yeah,
So like you're like, it looks. You just crash the job and then restart it on a new kernel.
it'd be kind of cool if you didn't have to do that though. If it's like the message that you get back from the agent
Oh, like you could
is
race it. You want to race it?
yeah,
Yeah, you could. You
yeah,
could do race. Race is just the same as it's just another version of consensus. So you could even do A/B testing on new and old kernels where the same message for a time was being processed by two different kernels and then the result came back and got compared in some way before being passed on. That seems pretty feasible.
yeah, or even just noted. It's like here's the answer to your long-running job that you kicked off at this date timestamp. And it's like, oh, that's cool. The
Mm.
kernel is now faster. Brilliant.
Yeah. Yeah, so you
You
could
know,
race it
because
when there's a new kernel.
yeah, yeah, okay. So yes to kernel changes at the agent, and
All right, so naming and namespacing, this concept of being able to register with every. Oh fuck, who am I registering with? I'm registering with the agent, right? So the agent has a registry.
one per agent.
Yeah. You don't have to store something in the registry, but it's there if you want it. Because
Okay.
if an agent looks like, this is the POSIX path slash other agent slash other agent,
Yeah.
every agent that is permitted to have children must be permitted to have a registry. Well, I guess you could separate those permissions, but the agent
Mm,
could have a registry where, like, this agent's version of Bob means something different to this agent's version of Bob.
yeah.
Because the path, so you're like, registry
There's
at
nothing.
path.
There's nothing stopping you doing that because the registry.
Well, the registry is addressable
just
by the POSIX
oh,
path
actually,
perfectly.
right. Oh yeah, 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 yeah. Um,
So I can be like,
that feels kind of cool.
it's kind of wicked actually. Like it's like you can have wild combinations of stuff and great isolation, very high precision in the way that you can recall it because you're just using POSIX pathing
Yeah,
to get at
yeah,
the registry contents.
yeah. And each Bob could have a different registry. I
Yeah.
could. That sounds pretty cool. When would you use that?
I'll tell you what's maybe even better or helpful is that the you could also have an implied registry. So once you had
Mm-hmm.
a collection of agents set up at a particular path, each agent you could ask to boot the kernel from that agent. So you could treat the
Mm-hmm.
running kernel like an image too that you wanted to clone. So you're just
Mm-hmm.
like, I want to take that kernel and make a new one over here.
Mm-hmm.
All right, so I mean that sounds all
Yeah.
great fun. What about the notion of cloning the actual agent? Because the agent has inside it, it's got like working files, codex log files. It's got all the state in it.
Mm-hmm. Mm-hmm.
We
Um,
Is there any point to clone it? Because the only thing that you're gonna do with that state is try to learn from it or process it. It doesn't feel like it really adds anything um to the next instantiation of itself. Like it needs background processing.
do you want to clone an agent? Agent being a virtual state. Um,
It's a kernel that has run for some time and has mutated its home directory, which is the space allocated to it to do whatever changes it needs to on the file system.
mhm.
It feels largely for diagnostics purposes than
Yeah,
anything else.
that's pretty niche because by cloning, would it like the clone all the running cores at that point?
I was just talking, I was not talking about cloning the message queue or the threads in
Mm-hmm.
process. I was talking
Mm-hmm.
about just cloning the current state of the home directory, but you couldn't clone the message queue because the senders would get confused.
Yeah, yeah, because you
You
know
couldn't
what.
clone the threads because you couldn't clone the message queue, but you could store like you could clone all the logs, all the records of the threads.
Yeah, yeah.
Yeah.
So if the clone didn't include the message queue, didn't include the running cores, then yeah, that'd be again an AB kind of
Yeah, I don't know
situation.
why you'd want to do that though, because it's not clear the use case. But so
No,
maybe let's
no,
just what I was trying to do here was just probe the limits of this design, and it's
yeah,
starting to feel to me like this design is the winner because it's very tight in a lot of our key areas like resiliency, simplicity, scalability, addressability, experimentation is good. You know,
yeah,
the using it as a lab, bursting through like 10 different iterations of the kernel
yeah,
very quickly, and then weighing it like that all works.
yeah.
Seems
And
good, eh?
I loved the virtual um, virtual agent style where anything to the right of that you really don't care because that gives
Internals.
a hell of a lot of ability to optimize that or constrict it. Only want to run it on a Cocoa. Only want to run on, you know,
Yeah, yeah.
this
It's
place.
implemented. It's dealer's choice. Like
Yeah,
whoever's dealing the cores gets to choose how that gets managed. So you can optimize the
yeah,
shit out of it if you want.
yeah, yeah.
All right. Well,
It feels pretty. It feels nice.
okay. It's good. It's good.
Mm.
No further
Mm.
questions then.
No.
Except implementation. So we've got a system that sort of works. We use it every day. It's recently had the OpenAI extension added to it, which I hope you enjoy.
Mm-hmm.
Um, which doesn't do much, but adds a bit of a nice. Oh, it does actually do something. It does do something.
Mm-hmm.
When I type here, it adds
Mm-hmm.
my selected file and what files are opened and stuff like that into the thread context.
Oh, oh, that's nice.
So
Oh, that
that's
is nice.
that's what it does. It's integrated with what you're
And
looking at.
and then presumably you could upload a file using the V Plus,
Yeah.
and then in thread, say stuff that in the repo somewhere.
Oh, right. But you know that you can just like paste files here, right?
Oh yeah, but by stuff it in the repo somewhere, I'm being um, vague on purpose. I don't want to necessarily have to figure out what the best place is. And something I've used in the past is getting
Oh, I see. Yeah.
the agent to even create a new folder inside of another folder. I don't really care as long as
Yeah.
when I refer to it, you know where it is.
All right. Yeah, true. You could do that. I would. Yep. So, Maxwell, the question is, do I do this work now? Because that feels like it's definitely better, but it's a bit of a rejigging. Like I don't have this queue. I don't have this
Mm-hmm.
core. I don't have threading in the core. Luckily, I deferred threading at all, so it's not like I've wasted any time there. But now I can do threading, but threading becomes this other thing. Um, I need to modify the MCP platform calls to fit this new shape so you can edit kernels, you can register kernels, and then add triggers at the same time because triggers feel like I want to make triggers as you suggested. I want to make triggers be the thing that kick off the work so that it's all just triggers instead of like some separate mechanism that deals with the queue or using, TCP/IP transmissions to put messages in the queue because there is no agent anymore. Like the agent is no longer a running virtual machine, so it can't receive
Yeah,
the web traffic that it used to. It has to be a file system thing because it's not real anymore. It's
yeah.
not silicon.
The big thing on workflows is the triggers, as you say. I think that's number one priority at the moment. But it given that this is um, seems a pretty solid approach. This seems like a prerequisite to doing triggers.
Does it though? Like I could do triggers. I could do triggers in a shitty form now, and then you could be up and working with some triggers.
Well, it depends how much, because that's going to be disposable work. Depends how much
True. It is
disposable work that
disposable,
is.
and then it's also like you would have started exploring in a system that was going to be completely changed out from under you.
Well,
Fuck.
it would look very similar, wouldn't it? Because I
Are
would
you
still
able
be,
to do? Are you able to do productive work if I add no further features?
yes,
For how long?
for sure for now. Next few days for sure.
So I
Um,
should go for this change now as minimally as possible. I should make
yeah,
this
um, yeah,
vagant
and
thing.
the reason I'm hesitating there is it seems like quite a lot of work.
I don't think it's a lot of work. It's because all of the hard bits are still the same. Like, a core is still just a host.
Yeah.
I just renamed it. Threading. Well, I know how to do threading. I didn't implement it, so that's easy. I can implement it without an existing thing in the way. The
Uh-huh.
queue is trivial because we have NFS, and I've done plenty of queues in the past on blockchains, so I know how to do messages that are stored in the file system effectively. So,
Okay. Well, it seems like it'd be sensible to go for this. If we're talking about, I don't know, a week's worth of work, there's nothing blocking me at the moment on the old version. I
mm,
don't think conceptually it's that much different because I'm still talking to agents.
yeah, so you have agent to agent communication at this point.
Yeah,
They can do long running jobs, like 10-minute long jobs, and probably like nested 10-minute long jobs.
yeah,
Um,
yeah. And triggers would be helpful, but it's not stopping me not having triggers yet. Um,
Fuck, Maxwell. We keep it just. When is it done?
well, we keep on uh, refining and getting better and better at the architecture. Is the problem, isn't it?
Right, because
Well,
we
it's a good,
do we
it's a
we
good
get
problem.
we get just enough going that we can do some experiments, and then we're like, oh shit, here's a problem. How do we solve it? We solve it, then we implement. We are not
Yeah,
going in circles because things are getting more and more structured. I know
yeah,
that much.
yeah.
But where
Well,
is the end point?
um, I guess diminishing returns when we, have one of these calls and there's no more wrinkles, there's no more, you know,
When
discussions
can we
on
use the
architecture.
system to ask it what it should be used for?
We could probably do that now. Um, it would be confined. I mean, this system is great for scalability, great for abstraction, all that kind of good stuff. But if you're to strip that away, I'm still talking to an agent, albeit it's just me. It's still got a thread. Um, the Where's the kernel at the moment? What would that equate to?
Well, kernels were images.
Yeah, so there's somewhere in the current version, is there somewhere I can say, right, I've been working on with the landing agent
Yep,
on a bunch of agents. And
yep.
it's like, yeah, happy with that. Now I want to stuff that somewhere.
Into images. You wanna
Hey,
create images? Yep. So you can do that right now.
yeah, so I just say, right, okay, happy with that. Put that in images so I can use them later, you know.
Yep.
Uh, and it would do it. And then I can come off into a completely separate uh, session, separate landing agent, and say, hey, can you bring up uh, the this agent, and that agent would be the place that knew where the workflow is for now, pending triggers. So that would still work. So other than beneath the hood, it's really quite different. There's not much at the interface between human and landing agent. This is going to change,
Okay.
except triggers.
Right. Um. Okay. So that means that you should be able to still experiment,
Yeah.
right? But I just feel like we're losing sight of what the fuck we were doing. Like we know how to build this agentic system, right? We're doing it. It's happening. It's
Mm.
getting better. but it's like we lost what it was for.
Well, it's for building workflows that do useful stuff, including talking about it stuff, and including
Are we saying that our solution to everything is a workflow of some sorts?
yeah.
And then what are we selling with that? Like, are we using it and then getting answers to things and then doing stuff? Are we
Yeah, I
letting
think
other
so.
people?
I think
It just feels a bit like the rug's being pulled out from under us. We're like, yeah, we got this cool thing, but not sure what to do with it.
well, there's plenty of jobs out there that I think we're agreed that we're not going to make it open yet, or at least
Mm,
everyone can decide. Which means we're the ones using this tool.
mm.
The output is something useful to someone else in return for money. Um,
Do you think that you could get Marla to use the VS Code interface?
I've not introduced it to her yet, but sure.
Do you want to have a go at it? Cause I'd like to get rid of the existing Dreamcatcher.ai site, but she finds that quite valuable. So it'd be great to get her to transition and to learn about what does she not like about the transition, if anything, right? Because I love the transition as it stands, but I admit it's not that cosmetically pleasing. However, I'm like, does it really matter when you get what you want, and especially if you got say like if you got this thing and then you're like, well, I can
Does it have different models in it?
you can only choose between 5 and codecs,
Okay, all right.
but I imagine you'll be able to get different models soon enough. Oh, you might actually be able to. I think if I configure it, you could have like Grok in there. I think.
Yeah, and the reason I asked that, that's one of the things that in the previous version she was loving, which was I'm going to talk to Gemini now. I'm going to talk to 5 now. Uh,
She's just like
for
switching
some,
models. Yeah. So I think
yeah.
that I could configure it to have a model switcher, and then,
Hmm.
your chats are just like happening in there. You've got all these
Yeah,
files. That's great. You even got search, whatever.
yeah,
Um, if she could be comfortable with it, that would be pretty good because then we can lift her over and be like, this is the thing.
yeah, yeah. Okay, I wanted to do
Yeah,
it,
give it a
and
shot. See how it goes.
probably the first thing she wants to do is a CRM style thing because she's got a lot of stuff flying around, and she's been asking for a CRM for a bit of time and kind of been hand rolling it.
Hmm.
So she could create, her own landing agent, uh, stick up all her files. Can you can do file uploads. Can you hook in Gmail? Not really until we get the triggers, I guess.
Nah, nah, not.
No, that's true.
No, but she can't do that in the existing one either.
Yeah.
You might be able to do it with MCP servers. So like hooking up Gmail using an MCP server might be a possibility.
Okay. I know
And
Gmail's
then
got an NCP endpoint.
what's that?
Gmail's already got an NCP endpoint, isn't it? Just don't. I've not checked to see whether it actually works.
So basically connectivity to the rest of the world, and then there'll be questions about user interface.
Yeah.
She doesn't seem like a girl who uses the command line that much.
No. But I can foreshadow that. and saying, you know, uh,
She only needs to know one command, right? Codex.
yeah, yeah.
Google doesn't expose a native one.
Yeah. Okay.
Oh, no, I know what you get. I absolutely know what you can do. Zapier,
Aha, of course.
MCP. Zapier MCP, AI in action. Connect your AI to any app. Yep, cool. So, get
Alright.
started. Any app you said.
Well, Zapier
Get your
definitely would do it.
get your MCP client added. Oh, so we could add our stuff here. Okay, get started. Must I sign up? Come the fluff on. You don't have GitHub? You animals. Put my email address on the whole internet. Whatever. You only spam once. What's your role? I think I'm marketing. Company size is there is no top apps.
Sucks this. Skip. No,
Gmail.
no, no. Yeah,
Oh, settle down. Settle down.
Okay. Sorry, I usually go skip.
Yeah, that's why you end up skipping right past the stuff you were looking for. Right, start connecting your AI assistants. Okay, MCP client. Oh, yeah, okay, I'm the. Start with ChatGPT. Do you mind if I try this out just to make sure we can do it?
Yeah, go for it. Yeah.
We're gonna add a tool. Okay, add Gmail tool. Get attachment, find email. Add label, archive email, create draft,
Just read, basically.
find email, right?
Yeah.
Oh. Oh, I can. Oh, it's that easy.
Okay.
See, edit, download, permalink, delete your contacts. Manage drafts and send emails. Read, compose, and send emails.
That one, yes.
Okay.
Read, yes.
Okay.
Is that connected? That's why it's still showing connect.
It's grayed out like my hair. Why is it? I already did that. Anyway, whatever. It looks like it's pretty straightforward, right? So if we did Zapier, and then you could add that as we would connect as a client to Zapier, and then you'd have all your stuff, and then you could codex to your heart's content.
How would I make that available? Back on the portal. So where would that go?
Oh Christ. I think didn't you just finish telling me that the answer to every question is a workflow?
Yeah.
So you'd have an agent that would spin up, that would walk you through hooking up all that stuff, and then it would give you a kernel that was provisioned with the MCP servers that Zapier provided, and then the next time you boot it, provided it's got your secrets, then you would have MCP access to whatever Zapier provided you. You could probably spend a long time having fun with that.
Yeah. Okay. I give it a go. See if it works out of the box.
And then that way, yeah, I guess we can have an agent that can give you some status on how well your connectivity is going. So what you could, there's a funny way here hear me out for just a second.
Mm-hmm.
A way that you could make. How am I going to describe this? There's a way that you could make a reporting system that was pure plain text. So, for example,
Mm-hmm.
because we've got these files
Mm-hmm.
and they look pretty and whatever, and you can render them however you like, what we could do is make an agent that went through and, for example, checked the status of your connectivity to various services like Gmail and all that, and then it wrote down the status with like status November the 12th 1023 report by the connectivity management agent, and then it would just have like a list of checkboxes that ticked off different services, and then gave you like links to click on if you wanted another one, where the link simply tells the agent, hey, I want to hook up my GitHub account now.
Mm-hmm.
And so the idea there is that we can present the information back to the user as just documents that got edited.
Mm-hmm.
But then again, I guess that begs the question, who are the users and what are they using it for? And is VS Code the way that we want to do that? I'm not so sure. But then again, maybe it is, because remember I told you there was an idea I had to make a Chrome extension that would it would make our system aware of where your browser tabs were so that it could reposition them for you.
Mm.
But if we make a VS Code extension, then it can do the same, but for VS Code, where it can open files, rearrange the window layout, trigger different agents when different things happen, see what documents you're browsing through or reading, and add that into context, trip off AI jobs.
Mm-hmm.
You know, so like there's a suite of functionality that we could deliver from a VS Code agent
Mm-hmm.
extension, sorry,
Mm-hmm.
which feels like more powerful than a Chrome extension, because the Chrome extension would only really be a window manager, but the VS Code extension would be kind of more than that. Like it would integrate with the agents more deeper.
Yeah. Yeah. I think that should work, shouldn't it?
Right. Well, yeah. And then we also got this thing that we're like, we need a viewer to be able to see inside the system. And so that's a piece of work, but it's kind of like how I'd imagine I would interact with the system,
Yeah.
where I'd just be looking at that graph view and jumping into different agents or sending in inputs or whatever.
Yeah. 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 That's another piece of work, isn't it? Um. Hmm. Okay. The
So,
original question was what to do. Do you build out this new architecture?
yeah.
I think so.
So I'll stop what I'm
Because,
doing and I'll build out this new agent kernel core
yeah. And
model.
well, notwithstanding all the benefits that come from that, the main thing is that allows for triggers. And you're not going to have to do triggers twice because I don't need triggers yet because
True. Yep.
I
I
can
won't
still
have to
do
do triggers
workflows.
twice.
Yeah.
Okay.
Okay.
And
Go ahead.
then we still need to know who we're making it for. Like,
Well, there's plenty of plenty of stuff coming from Marlow. People who want stuff.
That stuff,
Um,
can it be delivered as kernels?
I'm not sure because they probably want something fancier.
Fancier like a
Um,
UI?
yeah, probably.
Mate,
I'm
we
not
can give
sure
them a
though.
UI.
Yeah,
But
I'm not sure
how,
about that.
like,
But
how fancy does the UI have to be? Because, um, what I'm learning is that you can make, using that, the veg model there, you can make some really good UIs because the kernel's just like set up to, you know how I said the kernel needs to recognize different message types, like, hey,
mm,
this is an interaction, but it could also recognize, hey, I want a view, which just fires up a web page. It just becomes a web server at that point.
all right. In that case, I guess the only other thing is packaging it up as a separate computer off where you go. People pay for that.
Ah, yes, they would.
It's a point solution, isn't it? That's the
Like pennies in front of a
yeah.
steamroller, and then there's this thing that I'm like, come on, like we should be on this board.
Yeah, probably are going to be soon enough.
We should be on this board. I mean, it's just easy.
I think it's inevitable. I mean, what are these things? Black box AI pack
Like some of
historian.
these are lame, right? But you can
Yeah.
actually look at things like if I go to so codex, we would come in at we're at 250 mil for the last week, so we'd be number 10.
It's kind of cool. It's a bit of a vanity metric, but it's kind of cool.
Yeah, we'd be number 10. And then if we switch to Grok 4 Coda, sorry, Grok Code Fast 1, we would probably be. I reckon for our same spin, we would have been hitting. We'd probably be number 6 because the jump from 6 to 5 is large,
Mm.
but
Yeah.
like I'm like, it should be there and our name should be there. And then when you go to look at it, it's like a splash page or a landing page that is just like, hey, you can join us, but you need to pay $1,000 membership fee and you'll get $1,000 of tokens. But you need to prove to us that you're worth the time for us to support you because we're kind of busy.
Yeah. Yeah. I agree.
I don't know, Maxwell. It doesn't
Mm.
seem as clear as it once did. The power
Well,
seems very real. Like we're like, holy shit, we can do this stuff. But it's like, so what?
it's again, it's an embarrassment of riches, isn't it? It's we could use this for many things.
I
But
want to use it for things that are private, though. I feel like I want to sit there and ponder what to do with a bot and then do that.
I agree with that. And the once we get triggers and workflows up, it should be matter of like a couple of days to get any particular thing up.
Okay, so once I do this change,
Mm-hmm.
and once we do, admittedly, some troubleshooting with workflows, you reckon that we're sort of in user mode then? Like we've got everything we need to use the tool at that point?
Yeah, I think so. Especially if we can get them a nice, pretty GUI that they can go in, uh, auth into it, um,
So you'd
upload,
right, so
you
you'd be
know.
delivering a solution to some people who asked for something where they wanted a pretty UI. We gave them a pretty UI. It ran on the Dreamcatcher platform. They paid their token money in as the subscription,
Yep.
and then that sort of helps us show as the leaderboard because we're like Dreamcatcher platform, but actually that's counting all the tokens that these point solutions are pulling in as well,
Yeah. Yeah.
right?
And
And then we analyze the performance using our platform to make it better for the AI side of things. The baked code, whatever, it
yeah,
just gets some bug improvements here and there, but largely it stays static.
yeah, and we can use it for our own stuff, but to get some cash in and some usage in, and
But then we're just app builders, right?
um,
Specialized ones, sure, but we're just
well,
contract app builders.
I wouldn't expect to do that for very long because,
It's just like a snack along the way, right?
yeah, yeah, and a bit of learning from so that we don't get any blind spots that bite us later on.
Right, but does it need to be a point solution to figure out those blind spots?
It would certainly help just get other people to use it in the same way as asking Marl to use it, saying, "Hey,
Hmm. I'm starting to wonder about that philosophy though, because when you think about what we just came up with the queue and all that, I'm like that is so close to the fundamentals of computing and so general that it's not really a case of blind spot anymore because we also don't have that much movement, like we can't, like once we develop that it's like, well, what do you fucking want? We don't have any more moves after that, like
yeah, yeah,
it's
no, I
it's
agree,
it's got some
I
odd
agree."
properties about it that it's so general.
Well, I think the decision we came to last time still is right. Is that uh, it's not a B2C, it's not open. Um,
I
so
think I think it's basically a B to me and you. Like it's a B
yeah,
to us, and then we'll figure out what to do. Look, yeah. Sorry to keep dragging this on, but yeah. Okay, so I'll make the thing,
mm,
and then we'll be ready to burn tokens in pursuit of
yeah,
enlightenment,
yes,
right?
yeah, yeah. Okay, good.
Man,
Right.
I
Well,
hope this is all that is required.
yeah. So do I. But what else is there? Well, there's no point asking that at this point. I can't see anything.
I'm tired,
Uh,
buddy. I'm tired. We've been running at this thing super hard for the last few weeks.
yeah.
Um,
Okay. Well, let's leave it there because I need to get on as
all right, buddy.
well. And
Yeah, yeah, no worries, no worries. I'll
um,
I'll stop the video. I'll start uploading, and